Now, there are other types of scanning techniques other than using TCP. In fact, you can use ICMP and UDP, and even in some cases ARP, to scan a network to see if a host is up. ICMP and UDP scans are somewhat different from TCP scans in several ways. First of all, neither use flags because neither control or establish connections. Now, UDP is kind of the sister protocol to TCP in the transport layer of the OSI model. UDP does use ports, although it doesn't have to, and you'll see common application-level protocols use UDP. Some examples might be DNS, which uses UDP 53, and DHCP, which can use UDP 67. Now, ICMP doesn't use ports at all. Ports don't have any meaning at the network layer, nor with ICMP. In addition to scanning techniques, ICMP can be used to conduct denial of service attacks on different hosts, and that's something we'll talk about a little bit later in the course. Now, as I said, ICMP is a Layer 3 protocol. That means the network layer of the OSI model, and it's primarily used for maintenance purposes. We usually see ICMP used when we conduct a ping of a host, when we ping a host at the command prompt to see if it's up or not. There are also other commands that can use ICMP, such as traceroute, and that basically uses ICMP to determine the distance in hops between two hosts. Now, ICMP scanning can be used to determine if the hosts are live and up on the network, but beyond that, they don't really tell you what ports are open or closed, although, as I mentioned, with UDP, a certain type of ICMP response back can tell you if a port is closed or not. Now, ICMP is primarily used in terms of ping sweeping networks. You could send one to one host, but what you really want to do is scan an entire subnet with it. So that's called a ping sweep. And you would send ICMP echo requests to the host, and if the host is alive, you'll get an ICMP reply back. Now, a lot of network devices block ICMP, so they're basically ineffective in scanning a network. What you might do in that case is use ARP requests to see if a host is alive or not. And in fact, a lot of Nmap scans use ARP by default. Now, UDP, as I said, is a little bit different from TCP in that it does not send the three-way handshake. It doesn't use flags because it doesn't control the connection. And you may use UDP to get responses from hosts that don't respond to TCP scans. Because UDP is connectionless, if you send traffic to a UDP port on that target host, it won't respond when the port's open. It doesn't need to. However, you can use UDP to determine if a port is closed. If the port is closed, you may get certain ICMP responses back. For example, sending a UDP datagram without a port bound to it can cause the host to return an ICMP unreachable packet, and that tells you that the port is closed. Let's go ahead and take a look at Nmap, and I'll show you some of the different scans that can be run using ICMP and UDP. Okay, we're in Nmap, and what I'd like to do is show you just a couple of different scans that can be ran using UDP and ICMP. And basically, if you were to hit your drop-down box here, you could see a ping scan set up here. And a ping scan really uses ARP. If you run a Wireshark capture, you'll see that what's actually happening is ARP requests are going back to see if a particular host is up or not, or a series of hosts. But it's still considered a ping scan. Now, the command to do this is -SN and then your target range. And there are other commands you can use to run ICMP scans that use ICMP on the network, and I'll show you those a little bit later when we look at a Wireshark capture. Now, you can also run UDP types of scans, and here in this intense scan plus UDP, we see that the -SU is really what causes a UDP scan to run, and there are other options in here. Frequently, you'll find that a lot of these types of scans we run, especially UDP scans, are run in combination with other types of switches, because we want to get the most of our money. When we scan, we want to get a lot of different things back. So we'll scan using a stealth type of method, the send scan, and also scan at the same time using UDP. We'll also send different types of packets to determine OS fingerprinting, for example. So a lot of these scans are used in combination with each other, not necessarily by themselves. But a UDP scan is basically -S and a capital U. Later, we're going to look at a Wireshark scan that shows all of these different scans in the capture itself, and I'll show you what the traffic actually looks like as it travels across the network. So that's ICMP and UDP, and again, we'll take a little bit of a look later at how those actually look when they're used to scan a host or a network.